For this lesson, we're going to be continuing our look at quadratic relations, and this is another look, at least a second look, where we're going to be focusing on solving problems, specifically word problems. So some of the concepts that we'll be using, of course, anything that we've really covered in quadratics is applicable here, but a couple of things that really you want to focus on, the common things you're going to see. You're going to be asked for roots, and don't forget that that may be x-intercepts, that could be solutions, could be the word that's used there, or zeros. Generally, all four of those can be together, and if that's the case, you're generally going to want to be using factoring if possible, and I only want you using quadratic formula if there's a really good reason not to do factoring. Maybe factoring doesn't work, or the numbers involved are particularly nasty and you don't think you're going to be able to come up with the integers you need for factoring. Now we also have other options. So this is if we're trying to find the roots, the zeros, where something hits the ground, where something crosses a certain line, that sort of thing. On the other hand, the vertex is also very useful, and that's going to be what we're going to use to find maximum or minimum. What is the maximum or minimum? When or where does that occur? The vertex gives you both of those pieces of information. Grouped together, maximum and minimum are sometimes referred to as optimal value. Plus there are other just regular language things. You might get a highest point or the highest value, the lowest point or the lowest value. We've learned several methods of finding the vertex: factoring, partial factoring, completing the square. And you actually also have the option, technically you could use the quadratic formula to find the roots and then find the midpoint of those values. It is going to be exceedingly rare that that's the approach that I'm going to expect you to take. And don't forget, there is value in sketching. If you're having a hard time understanding what the question's asking for, then a sketch might help put the whole situation into perspective for you. Okay, so let's take a look at a few examples. So in the first one, we have an example from a fire department. An aerial ladder is something that would be on the back of a fire truck, and here we have a hose being placed there. The hose sprays water on a forest fire, and the height of the water is modeled by this equation. So I'm just going to go ahead and put in a very quick diagram. So there's the ground, there's my truck, there is a ladder on the truck, and there is a fire hose on the end of the ladder, and that fire hose is, I'll even make this red, that fire hose is putting water on a fire. Okay, so there's our idea, and if we were to superimpose coordinate axes over this, just to give you an idea, so here would be my height, and the fire hose is firing water out from that starting location in an arc, and then along here is probably going to be, I'm just going to go back and check the equation, yes, along the horizontal is my distance. So we're going to be looking at how far away is the fire to aim the water and have it land on the fire. Okay, so let's take a look at the questions that are being asked. What is the maximum height reached by the water? As soon as I see the word maximum, I am immediately thinking vertex. But then I look back at my equation, I see that I have vertex form. So the vertex in that equation is, this is d minus 1 in the brackets, so that's a 1. And this is 9, so that's a 9. The sign inside the bracket changed from -1 to +1. The sign outside the bracket stayed the same. Now normally we would have vertex form y equals a x minus h all squared plus k. But we have d and h, so how do these line up with each other? H and y, so it looks like those are the same, and we have, instead of x, we have our d. So coming down here, normally this is an x and a y, but x is actually a d and y is actually an h. So this 1 refers to a distance, this 9 refers to a height. So what is the maximum height reached by the water? We get that from here. Therefore, the maximum height is 9 meters. A more condensed way you could have said that is you could say h with a subscript max is equal to 9. But I realize in writing this now, I don't particularly like that because I like the concluding statement here because you would include the units of meters. And that's actually really quite important here. So let's stick with that concluding statement. All right, let's take a look at the other one. It says, at what horizontal distance from the nozzle is the maximum height reached? So let me go back to our diagram again. So we're trying to find, maybe I didn't show it super well here, but the idea is that the path goes up and then tilts down again. So our maximum height is there, and so we found what that maximum height was, and this question is also asking how far away from the nozzle does that maximum height occur. So what horizontal distance from the nozzle? Well, what horizontal distance? That's coming from here, the d value, and that d value is equal to 1. So therefore, the maximum height occurs 1 meter horizontally. How do I say that? Sorry, the pen gets less responsive when I get to the bottom of the page there. Horizontally. From the nozzle. Okay, so the vertex has provided us two actually very useful pieces of information there. This is a continuation, but you can see now I've got a part C and a part D. What is the height of the aerial ladder? Well, we don't actually know that. Don't make the mistake of thinking that's here. That would be the y-intercept, but that isn't the y-intercept. That's the y-coordinate of the vertex. So what we actually want for this one, the height of the aerial ladder is the same as the initial height of the water stream. And if that's the case, then that means we're looking for the y-intercept, which of course is not a y-intercept in this case. We've talked about that already. It's actually the h-intercept, and the way that we do that is normally we would set x equal to 0, but in this case we're going to set d equal to 0. So we're going to set this d value equal to 0, and we end up with h equals negative 2.25. We set d to 0, minus 1 all squared, plus 9. That's equal to, well, 0 minus 1 is just negative 1, and negative 1 all squared is positive 1. So this whole thing just turns into positive 1. Negative 2.25 times positive 1 is equal to, you know what, I should just write that out. So that's equal to negative 2.25, and this whole thing just becomes negative 1 all squared, which is positive 1. So that becomes negative 2.25 plus 9, and that would be equal to positive 6.75. So therefore, the height of the ladder is 6.75 meters. Just want to double check that. Yep. And finally, for this question, how high is the water when it is at a horizontal distance of 2 meters? So horizontal distance means d is equal to 2. So essentially, we are setting d equal to 2. So my height is equal to negative 2.25, but instead of d, I'm going to put 2 minus 1 all squared plus 9. Negative 2.25, well, 2 minus 1 is simply equal to 1 all squared plus 9. You can probably see where we're going here. We got this exact same result. So 1 squared is 1, so that's negative 2.25 plus 9, which is equal to 6.75. So therefore, the water is 6.75 meters high. And again, just referring to the diagram, so we found this maximum height occurred at 1, and we found that the height here was 6.75, and there's going to be another time when the height is 6.75, and that's going to be right here. And we calculated this, or sorry, we were given this. We were told 2, and we calculated it, and it turned out we got 6.75. I just want to use the diagram here to show you that it makes sense. Here's 1, and on either side of 1, by 1 unit distant, we've got 0 on the left and 2 on the right. So those two heights should be symmetric. They should be the same, and indeed they are. Okay, so there is question number 1. Take a look at question number 2. A ball is thrown into the air. Its height in meters after t seconds is given by this equation. When does it reach maximum height? So again, I see maximum. I see that I'm interested in a vertex. Now I take a look at this. Our first strategy for finding the vertex, if we're in standard form, is to complete the square. Now, is that even an option here? Well, once you have a little bit more experience with this, and there's nothing saying you can't just check things, my first step in completing the square is I'm going to factor out the a value. And these decimals, well, is this going to work out? But if you just run this through your calculator quickly, if you take a look, it turns out that 39.2 divided by negative 4.9, or just the 4.9 is what matters here, is equal to 8. So that actually, these two are going to divide nicely by that common factor. So actually, I'm going to write this as h equals, I take out the 4.9, I'm going to use a square bracket because I'm going to be needing another set of brackets shortly. I have t squared, and divided by negative 4.9 is actually equal to negative 8t plus 1.75. And now I'm going to complete the square on this. So I've got a negative 8 is my t term. I divide that by 2, and that's equal to negative 4. And then I take negative 4 and I square it, and I end up with positive 16. So now I get negative 4.9 t squared minus 8t, and I'm going to use this, so that's going to be plus 16 minus 16 inside the bracket, plus 1.75. h is equal to negative 4.9 square bracket. The reason for doing this whole process is to take those three terms, that's a perfect square trinomial, and write that as t minus 4 all squared. This minus 16 is still minus 16 inside the bracket, plus 1.75. Then we are going to multiply this 4.9 into the bracket. So we end up with negative 4.9 bracket t minus 4 all squared. So that's the first part of vertex form. And then we're going to do negative 4.9 multiplied by, and you can see we've got a negative 16 here, so that's actually going to be a positive now, and that works out to be 78.4 plus 1.75. And our last step here is to rewrite this 4.9 t minus 4 all squared. And then we've got 78.4 plus 1.75 ends up being plus 80.15. Now, I don't want you to think that I've answered the question here. This is a trap you want to avoid. All we've done here is, because we knew we wanted the vertex, we put this into vertex form. But now that I've actually got this in vertex form, I can say my vertex is at 4, 80.15, and I make the relationship between x and y, between the independent and dependent variable. And so here my independent variable is t, my dependent variable is h. The question wants to know when, which is a t, when does it reach the vertex, or what time is associated with the vertex. So there is our answer, that value of t. And so therefore it reaches maximum height after, and how long is it? 4 seconds. Continuing on the same page here, what is the maximum height? Well, that one is, I'll just rewrite it again. My vertex is 4, 80.15, and we said that this is a t and this one's an h, and so now we want the actual maximum height. Therefore, max height is, and it's going to be 80.15 meters. From what height is the ball released? The ball released, that would be, the ball is released at t equals 0, or you might also think of that as the initial height. Now you could, we've put this in vertex form, you could sub t equals 0 and solve for this. You could sub t equals 0 and solve for this. But you could also recognize that the initial height is the y-intercept, 1.75. Even if you were going to sub in, t equals 0 here, t equals 0 turns this into 0, turns this into 0, you end up with 1.75. So the initial height, which is the same as the y-intercept, and so we can say, basically, I'll just write it here, the y-intercept is equal to 1.75. That's here. So therefore, I'm going to actually say the initial height, and I'm going to spell it correctly. The initial height is 1.75 meters. And then finally, when does the ball hit the ground? So what does it mean for the ball to actually hit the ground? And I didn't do a drawing for this one, but if I were to do a drawing for this one, we have the ball is released from 1.75. We found that it reached a maximum height of 80 meters after 4 seconds. So way up here at 80. My scale, obviously, this doesn't have much value, but it gives us just a sense of things. This is time, so it's released from here, and then it's going to travel in that arc. So we are interested in this time. When does it hit the ground? And more importantly is, when it hits the ground, when does it hit the ground? At at h equals 0. The height is equal to 0. So what we're going to do is we're going to set height equal to 0 and solve. We could do that from here, or we could use our vertex form to do that. Either of those is fine. Now, since we've gone directly, since we have vertex form already, I'm going to suggest that. But you could also use set this equal to 0, set h equal to 0, and use the quadratic formula to find the zeros for that one. But I'm going to use this vertex form. So hopefully I can just copy that piece. Paste that in. So we'll start with that. And now we're going to set the height equal to 0. So I get 0 equals negative 4.9 t minus 4 all squared plus 80.15. I think I'm going to take this term over to the left side. So it becomes 4.9 t minus 4 all squared is equal to 80.15. Sorry, the equal signs can't line up anymore. I had no more room on the side here. When you're doing things by hand, sometimes things like that will happen. To get t minus 4 all by itself, I have to divide both sides by 4.9. Divide by 4.9. Now this is where, when you're doing calculations, you don't want to lose precision. So don't round your answers at this point in time. T minus 4 all squared is equal to, so 80.15 divided by 4.9 is unlikely to give a nice answer. And it doesn't give a nice answer. It gives 16 point, and I'm going to keep way more decimal places just to be on the safe side. So 35714. Now I'm writing that here, but the other thing I want you to understand is I'm actually keeping the entire answer in my calculator. And the reason for that is because now I'm going to take the square root of that thing. And so rather than writing this or typing this in my calculator again, I'm just going to keep the answer there. I'm going to take the square root of that answer. And I end up with, and again, I'm going to write these decimal places, but I'm actually going to keep them in my calculator. So it's 4.044396. 4.044396. And now t is equal to, I bring over this negative 4, it becomes positive 4. So it becomes 4 plus or minus 4.044, and I'm just going to make that 0.44. And this is approximately equal to, this is approximately equal to, and now think about time. I could add these two together, but if you take a look, this number 4.044 is a little bit bigger than 4. So when I subtract this, I'm going to end up with a negative number. Well, we can't have negative time. So I'm just going to put on the end here, but time is greater than 0. So t must be approximately equal to 4 plus 4.0444. And so t is equal to, in this case, that's 8 point, and again, that's an approximation. And it looks like that's just, I'm going to round that to 8.04. Probably could just round that to 8. Did it ask for a number of decimal places? It is not. It does not. So therefore, it hits the ground after 8 seconds. Okay, and one last problem to do. I think this tutorial is going, or this lesson is going a little longer, but that's the way these things go. The size of a television screen or a computer monitor is normally stated as the length of diagonal. So a television screen or a computer monitor is usually a rectangle, and so a diagonal would be here. So this one has a 38 centimeter diagonal. The width of the screen is 6 centimeters more than the height. So if this is the height, then the width is equal to the height plus 6. That's what they're telling us here. So there's a relationship between the width and the height. Find the dimensions of the screen. What do we want here? The width of the screen is this. Find the dimensions of the screen to the nearest tenth. Now, how do we relate these things together? Well, one thing is this is a rectangle. And as soon as you see that, hopefully you see a right-angled triangle, so Pythagorean theorem. So the relationship is actually 38 squared is equal to h squared plus w squared. but we don't want W. We're going to replace that with 38 squared equals h squared plus h plus 6 all squared. And I can start to work with this because I want to create a quadratic equation that I can work with. So 1444 h squared plus, now you might do this in line or you might do it in the side. I'm going to go ahead and do it in rough work just to remind people. H plus 6 all squared, and if I write that as h plus 6 times h plus 6, that's equal to h squared plus 6h plus 6h plus 36, which is equal to h squared plus 12h plus 36. So that goes here, h squared plus 12h plus 36. I'm going to gather everything over on the right hand side, so this becomes 0 equals h squared plus h squared is 2h squared plus 12h, and then we have 36 minus 1444, which actually is 1408, I believe. Just going to check that. 1408. One thing I might do immediately here is I notice that everything is even, so I'm actually going to divide every number in this by 2, because that doesn't actually change anything, but it does make things a little bit easier. The number's a little more manageable. That's still 0, but that's h squared, which means this is now a simple trinomial, plus 6h minus, and this is now 704. Now I suspect, and I could do this if I put the time into it, I suspect that this is actually factorable. This has worked out pretty nicely. But let's say for some reason you're intimidated by the 704, or you don't want to try to list out factors. You haven't got a really good strategy to use for this. So if that's the case, you could now do a couple of things. You could do vertex form, which is very manageable from here. But vertex form is kind of a roundabout way of doing this because we are looking for the solution to this. Now this is an interesting one because we're looking for the solution to this quadratic equation, which kind of means we're looking for the zeros of this, but the zeros of this are the same numbers that make this true. So that's something that's a tough one for students to deal with. So even though I could factor this, even though I could do this using completing the square, I'm just going to show you that sometimes it is okay. If you're a little overwhelmed by the numbers, then you can go ahead and use the quadratic formula. So the one thing to keep in mind though is that these are h's. So you need to remember that's taking the place of your x's, and here I have a equal 1, b equal 6, c equal negative 704. So the x in the quadratic formula, which we might want to write as h, depends on what you're comfortable with. I'm going to write it as x here, kind of in my rough work, is equal to plus or minus, sorry, I'm getting ahead of myself here. It's equal to negative b, which is negative 6, plus or minus, b squared is going to be 6 squared, minus 4 times 1 times negative 704, the square root of that whole thing, divided by 2 times 1. So that is equal to negative 6 plus or minus 36 plus, that's 2816, 2816 over 2. You can see that what's in the square root, which is the discriminant, is going to be greater than 0, so that's 2 solutions. Negative 6 plus or minus the square root of 2816, 2822, 2852 divided by 2. Now, if things work out the way I suspected they would, then I'm actually going to be able to take the square root of 2852 and get an actual, nope, I was wrong. It's not a perfect square. So provided I've actually done everything correctly here, which is making me second guess myself, that 2852 looks good. Just check 4 times 704 and make sure I did that correct. Yes, that's right. So it looks like this is I wouldn't have been able to factor this. It turns out this was not factorable. And so I continue from here, and I get two answers. So one of my answers is going to be h equals -6 plus the square root of 2852 divided by 2, and that is approximately equal to, so I take the square root of 2852, and I'm going to add that to -6, and then I'm going to divide that by 2. And I end up with approximately 23.7. Or I end up with h equals -6 minus the square root of 2852 divided by 2. Now, just to remind us, what does h stand for? H is the height of the screen, but h must be greater than 0. So I discard. Okay, there's no point in doing this. This is a negative number. I'm going to be subtracting a positive number, which means overall this is going to be negative. It's going to be a negative number minus another number is negative. So this can't be it. So that means this must be my answer. And what does the question actually want? Find the dimensions of the screen to the nearest tenth. So now that I know h, what is w? What was our original expression for w? W is h plus 6. W is equal to h plus 6, which is equal to approximately 23.7 plus 6, which is equal to approximately 29.7. Therefore, dimensions are 23.7 centimeters by 29.7 centimeters. And if you want to do a quick check of this, you could do the Pythagorean theorem check. Left side equals h squared plus w squared, which is equal to 23.7 all squared plus 29.7 all squared. Now you have to be careful. These are approximate values. So when we do this, we're only going to get something close to what we expect, but it won't necessarily be exact unless you've kept your exact values. And I end up with 1443.78. So within the allowances, what is my right side? We figured that was 38 squared, which is equal to 1444. And so within tolerances of the rounding that I've done, this actually does work out. So that's checked and confirmed. And I believe that's it. So there are some additional problems that you can try to practice more word problems.